Hi, Swam, welcome to you. I am Nikesh, and in this video, I will show you how to create your own class called statistic. And inside this class, I will add different kind of function based on measure of central tendency and measure of dispersion. For example, mean, median, mode, variance, covariance, and kurtosis and skewness. So, without wasting any more time, let's come to the code part. So, my class variable is always needed when you want to define your class. So my statistic is my class name, and always remember whenever you define your class name, always write in a camel case. Okay. So my first function is validation data. Okay. It is our first function, and inside this function I add a logic which means I add some condition which filter my data. If the data fulfill all the condition, then it should proceed to the next function, or if it is not valid, then it's raise some error. So let's see how to complete this function. If so my first condition is I want to check the data must be in list and it is not empty. Okay, data list or len of data to 0. If this condition is fulfilled, then simply raise value error right inside this non-empty list. Okay, it is my first condition, and my second condition, I want to check all the element inside a list must be a numbers. Okay, so let's see how to apply this. And inside this I have to provide x, and it is must be int and float. These are the data types. Okay, float for x in data. If it is true, then simply raise value error okay, and then okay, now it is completed. My validation function is complete. Now I'm going to create my mean function. Okay, how to create a mean means how to find the mean of a data. So simply I have to define my function name mean self data, and simply now I have to validate my function first, the data first. So that validate data, inside I have to provide my data. If it is true, means if there is no error, then simply I have to write a code to find. Okay, so of data divided by len of data, it is a function of a mean. To find the mean, simply I have to return. So my mean is completed. Now come to the mode part. Sorry, median. So again I have to verify my data. So dot if this condition is also fine, then simply I have to calculate my mean. Okay, so to calculate the mean, first I have to sort my data, because mean is the middle value of a data. Okay, when the data is arranged either in ascending or descending. Sort data, sorted data, and now I have to find the length, and is equal to length of my data, and then I have to also find the middle value, mid value, and divided by 2. Okay, now I have to find the mean. Suppose if and so if the length of a data divisible by 200 means if it is even, then simply I have to apply one function, return, okay, sort data, mm, mid value -1, and then have to add, okay, and whole I have to divide with 2. Okay, it is the way to find the median if the data is even. Okay, and else return, mm, sort, simply if the data is odd, for example, suppose 1 to 5. Okay, 3 is the middle value. From the left side of 3 there is 2 numbers, and from the right side of the 3 there is 2 numbers. So in this case you can easily find the middle value, but when the when the data is in even number, then you have to apply this logic. Okay, so my median is also complete. Now I have to write code for my mode. Self data. Again I have to check my data first, and if there is no error, then I have to find frequency is equal to 0. Sorry, I need a empty dictionary, and max value is equal to 0. Okay, and then I have to run a loop for item in data. Next, frequency of item is equal to frequency dot get, and if my item is 0, and if item is not present, then add 1. Okay, it means if item is not present, then add item, and if item is already present, then increase the value with 1. Okay, now I have to, if frequency of item is greater than my max value, then simply max value is equal to frequency item. Okay, so I am only counting the max value from a dictionary. Okay, and after that I have to calculate mode. Key for key and value on frequency that items. This function convert the dictionary into a tuples, and okay, and if value is equal to max value, okay, from this I will get the max, means the mode. Okay, and then I have simply return. There is condition, suppose if there are no mode, means all numbers are unique. At that time we don't have any mode, so I have to handle this situation. No mode found if len of mode is equal to len of frequency. Okay, else return my mode. It is also done. Now mean completed, median completed, mode completed. Now come to the variance. Okay, let's see how to find the variance. Self data, self variance. If there is no error, then I have to find my variance. So to find the variance, the formula of the variance is sigma of I is equal to 1 to n square of x minus mean divided by n minus 2. If you n minus 2 is the formula of a sample variance. Okay, so in this function I will find the variance of a sample. Let's see, mean value. I am again calling my mean function to find the mean, and I have to provide my data, and now I have to calculate the mean. X minus, let me rename this x mean. Okay. X minus x mean to 2 for x in data. Okay, let's mean into this sum. Okay, and whole divided by len of data minus 1. It is completed. Now variance is also completed. Now I have to find variance and coefficient of variation. Okay, coefficient of variation and self dot data, self dot Go to data. Now I have to find the formula of the coefficient of variation is standard mean divided by standard deviation into 100. So it's give in a percent. So let's me first find the mean value. Again I have to call my mean function self dot mean equal to data. Now I'm able to get my mean and I have to find also my standard deviation. First I have to define my standard deviation. Okay, don't worry. Let's make create a function for the standard deviation first. Std so data. So basically standard deviation is the square root of the variance. So it is easy to find. Let's me first self data. Okay, and after simply I have to find the self dot variance of data. I have to store it in a where. Okay, and it is the square. I have to 0.5 and that's me return. So my standard deviation is also complete now. Now come to the coefficient of variation. Standard deviation value. I'm storing the standard deviation in a value called standard deviation value. Self dot std and inside this I have to provide my data. My standard deviation also completed. Now I have to write a code to extract the coefficient of variation. The formula is very simple. Mean divided by standard deviation value into 100. It is now it is completed coefficient. Now I am going to show you how to find the covariance. Okay, covariance covariance. To find the covariance, we need two data because covariance tell about the relation either it is positive, negative, or neutral. So to find this kind of relation, we have to provide two different data. It is my another data, and let me check first self dot validate self dot validate for the data. If both data is don't have any error, then I have to calculate the covariance. The formula of covariance is x sigma of x minus x mean into y minus y mean divided by n minus 2 for sample, and if you want to population then simply divide with the n. So let's see. First I have to calculate mean of x means first data. X mean is equal to self dot. Now I'm calling my mean function again and I have to provide my data. From this I will able to extract my mean value for the first data, and second data which is y mean self dot mean, and this time I provide my another data. my x. Now I have to run a loop for this. Okay, x x minus x mean x mean into y y minus y mean for x and y in GIF data and other data. Okay, it is okay. And formula is x minus x bar into y minus y bar divided by length of any data, because the both data length is same. Data minus 1 I have to put in bracket. Okay. My covariance is also done now. Okay, it is done. Now I will show you how to find the correlation. It is little difficult. Okay, correlation. To find the correlation, we also have to provide the two different data. Okay, because it's give the strength of the relation between the two data. So self that data and other data. Self that validate. Now I have to check my first data. If there is no error, then I have to check my another data. And this time I have to provide my second data, which is other data. And if it is true, then I have to find the formula of correlation is covariance of x and y divided by standard deviation of x and into standard deviation of y. So let's me convert into a logic. So first I have to find the covariance of x and y. To find the covariance of x and y, I simply use this code. Okay. Numerator. Okay, it is done. But I have to remove this. Okay. Numerator is complete. Now I have to find the denominator. Root of 1 means of x is equal to x is equal to, how to find, I have to find the standard deviation. And the standard deviation. Also I have to sum. Here also I have to write the sum because there are multiple items. My numerator is complete. I have to find out the numerator. Simply I have to use sum of x. To find the standard deviation, I have to, let's see, x minus x mean to x in data. Okay, and to find the standard deviation we have to divide with 0.5. Now I will copy this and change it other data for the other data. Okay, this time I have to y mean with y. So it is also done. Now I have to calculate the correlation. Vector divided by denominator of x into this correlation is also complete. Now linearity also have to change this y. That's looking good. And then I will show you now. I will show you how to find the skewness. Okay, to find the skewness, let me define my function name first. Skewness self dot data, and this time self dot error data. If there is no error, then again first I have to find the mean value is equal to self dot mean, and inside this I have to provide my data. And now I have to find the standard deviation. It is required to find the skewness. Okay, simply self dot std. I'm calling my standard deviation function and providing the data, and also I have to provide the length of the data. It is also required to find the skewness of data. So now I have to apply the logic. I think I have to x minus mean value into 3. This time when you find the skewness, you have to find the cube. Okay, for x in data, it is done. I have to submit. Okay, and divide it with n. And blank totally now, I don't know why. And I have to find into, okay, divided by standard value to 3. So it is the formula to find the, yes, let me check it. Yes, it is. I have to return it. Okay, my skewness is complete. Now this video I will show you how to find the kurtosis. Kurtosis. data, and this time again I have to set my data. So this I have to provide my data. So for this time also I have to find, so I'm going to use the same code. All these things are need to find the kurtosis. So simply sum of x minus x mean x mean x mean into 4. This time I have to find this with 4 mean value. I have to provide mean value and for x in data. Okay, and all this I have to divide with 10 and and I have to standard value into to 4. This time I need 4 and have to minus with 3. Okay, so let's see. All my function is completed. Let's see if there is any error or not. I have to create a object first. Now that now first I show you mean. How to find the mean. Set this provide one. Let's find the mean of this 5 number. It's 3. It is working good. Now see dot median. Okay, 1 2 3 4 5 6 7 8. Let's see 4.5. It is also good. Yeah, it's working good now. Mean complete, median complete. Now I'll show you find the mode. Let's me provide for mode. There are multiple 9. Sorry. It is also quite saying the property had no attribute of item. Let's see mode. Yes, 9. Also, because 9 is 2 times. Now it is also working. Mean, median, mode. Let's find the variance. 7.5. It is also good now. And let's find the standard deviation. STD. It is also good, working good. 9.73. Let's see this time covariance, coefficient of variation. Okay, Yeah, it is also working good. Now covariance. To find the covariance, this time I have to apply I have to give two data sets. Okay, 1 2 3 4 5 6 7 8 7 8 9 and again 2. Let's see, it's taking extra time. No objected covariance. Okay, yeah, it's also working good. Covariance is 7.5 and correlation this time. Let's see the correlation. Mm, name y is not defined. Let's see where is error. Okay, okay, y. Then again I have to run the object, and after this I think problem will be solved. Yes, it is solved now. The relation in 0.93. It is true because almost all the element is same except the ninth and 2. Okay, so let's see the skewness. Skewness. Let's check. Yeah, it is also good. And now let's see the kurtosis. Yes, it is also working fine. So this is the code, guys. If you want to suggest me for the better optimization, then you please share your thought with me. And thank you for watching this video. I'm also learning nowadays, but I like to express my opinion and my logic with the people. I hope this will help you to improve your logic and improve your Python. And because this standard deviation, measure of central tendency and measure of dispersion are very important in data science. That's why I am created this class, my statistic. So thank you for watching this video.